Okay, so here we go. We're on part 2 of lesson 2.5. Okay, today this will be solving quadratic equations using the square root property. We're going to be doing that. And then we're also going to be using a process called completing the square. Okay, the square root property is involved in completing the square. So we're going to kind of build on the same idea today. So solve using the square root property. So the square root property says this. This is the square root property. If x squared is equals to some number, let it be k. If x squared is equal to k, then x is equal to plus or minus the square root of k. If x is equal to k, then x is equal to the positive or negative square root of k. Okay? And so why is that? Why is that? How do I undo a square? What's the inverse operation? I know if I'm trying to undo addition, I subtract. If I'm trying to undo multiplication, I divide. If I'm trying to undo squaring, I could square root it. By the same measure, if I was trying to undo something that had been square rooted, I would square it, right? So these are inverse operations. So if I'm given a situation and you saw this in your homework last night, hey, no. You saw this in your homework last night. We said I might have x squared minus 9 is equal to 0. One way to look at that is as a difference of two squares, right? We worked on factoring. We said I've got x plus 3 and x minus 3 equals 0. If I set each piece equal to 0, then my answers are x equals negative 3 and x equals positive 3, right? That was one way. That's to see this x squared minus 9 as a difference of two squares. The other way is by using the square root property, which is to say if x squared minus 9 equals 0, then I want to get the x squared term by itself. How do I do that? Add what?
9.
Add the 9? So now x squared is equal to 9. Still trying to isolate x. X right now is being squared, so I can undo that by square rooting. When I square root both sides, I'm left with x is equal to, and I want you to consider that every time you take the square root, you are considering both the positive and the negative option that could have made that number, right? So plus or minus the square root of 9. Well, what is the square root of 9? 3. So x must be equal to positive or negative 3. If you broke that down, you could see x equals positive 3, x equals negative 3, which is the exact same thing we had over here. Okay. So this is called the square root property, and it works. You can isolate x.
Is it always going to be plus?
Plus or minus. Anytime you write down that you are taking the square root, you're going to have a positive and a negative option. Yeah, every single time. Okay. So we've got some steps here that I want to write down. This works if there is no x term. If there is no x term. So that would be like the b part. So you're going to have ax squared plus bx plus c, and you're going to see the x squared piece, and you may see the c piece. You want to use this method when you don't have any x term by itself. As long as there is an x term, you need to go to factoring or some other way.
And that only works
Okay.
with the thing that you just showed us.
Right. So when I'm using the square root property, there is no x term in my equation. That's why I get to use it. You with me? Okay, so if you see x, there's going to be a different way. There's going to be something else that we could use. All right, so how to use the square root property. The first thing we want to do is isolate the x squared term. We want to get it all by itself. Isolate the x squared term. Once you have the x squared term by itself, then you're going to root both sides. So take the square root of both sides. Keep in mind that you're going to have the positive or negative option for your square root. Every single time you're going to consider positive or negative. The reason we do that, again, if I say, what's the square root of 5? Well, what do you say? Positive 25. What's the square root of 25? Positive 5, or I could have had negative 5 times negative 5, and I would have still gotten 25. Okay. And then the last thing you want to do here is simplify. Simplify. Okay, I know you all have been reducing radical expressions in geometry. That's what this is talking about. Making sure that we've got this radical as small as it can be. Okay? All right, so the first example here, this is example 6. And our problem says x squared minus 8 is equal to 0. X squared minus 8 equals 0. So step 1, in order to solve, we want to do what? Isolate the square root. So yesterday we said, hey, this is a difference of squares. I want to factor it. Notice that 8's not a perfect square. So this is not a difference of squares. So the factoring here is not even an option. Okay? So you want to add 8 to both sides. So now I have x squared is equal to 8. What's next? Square root both sides. When I square root x squared, that leaves me x. And x is going to equal positive or negative square root 8. We want to simplify the 8. What's it in 8? 3 2s. 2 square roots of 2. So I want to pull one set of 2s. So I'm going to have plus or minus 2 square root of 2 left over. So x is equal to plus or minus 2 square root 2. Okay. Right, so a couple of things. Plus or minus 2 square root 2. I just threw these into a calculator really quickly because I wanted to be able to show you. Populate. Jeez. I just took pictures of this and I'm not seeing it now. Hold on. We're syncing to the cloud. Y'all just wait. Okay, so I just took a picture of this. I threw it in the calculator just a few seconds before you guys walked in here. If I take the square root of 8, that's 2.82. If I pull the 2 out in front, that would be a positive 2.82 or a negative 2.82. Can y'all see that? Okay. The reason that I wanted to show you that is because if you graph this picture, x squared minus 8, that's our function that we just started with. If you graph that, what you can see is your roots are at positive 2.82 and negative 2.82. Everybody okay with that? Okay, so we're not just finding nothing here. We're finding the actual x-intercepts. Okay. All right, let's go on. This is example 7. Example 7, it says 4x squared plus 1 equals 7. 4x squared plus 1 equals 7. So your first check before you try to use the square root property is to see if there is a b term. Is there a b term? Anything that has just one little lonely x? No. Since that's the case, you can isolate the x squared piece. Okay, so what is my first move to isolate that x squared? Subtract 1. Good. So 4x squared equals what's 7 minus 1? 6. Okay. Almost. We're almost ready to square root. Divide it by 4 first. So x squared is equal to 6/4. And then, now we're going to square root both sides. So x is equal to, I need you to remember that if I'm square rooting a quotient, a over b, that's the same thing as square rooting a and dividing by the square root of b. You remember that those are the same? So what we really have is plus or minus on top the square root of 6, on bottom the square root of 4, which is 2. So that bottom could be simplified. Plus or minus the square root of 6 over 2 would be our final answer there. Plus or minus the square root of 6 over 2. Because I square rooted a quotient, right? The 6 over 4. I could do the square root of the top divided by the square root of the bottom. And I do know that the square root of the bottom right there is 2. Okay, that's kind of the benefit of writing it that way. Otherwise, you have to rationalize the denominator, which is also an option. Okay? Questions here? No? Okay. The try it for these two problems actually looks different than either one of them. So I want to do the try it because I feel like it's a different look at the same idea. So the equation for the try it says 3, open parentheses, x minus 4 squared equals 15. 3 parentheses, x minus 4 squared equals 15. Okay. So one option here is to hop out that x minus 4. We could write it as x minus 4 times itself, right? We could go through all of that. We could then push in the 3, and then we could factor. We could go through the whole deal. Or we could use the square root property, which is going to save us a lot of time. Okay? This is something, x minus 4 squared. We want to isolate the squared part. So right now, what's with the squared part? Okay, x minus 4 is inside parentheses, but what's on the outside? The 3. What's the 3 doing? It's multiplying. The 3 is multiplying by that piece in parentheses. So we want to get rid of it. How do I undo something that's being multiplied? Divide. You can't push it through the x minus 4, so the option there was distribute. I can't do that because of the power right there. You were just kidding, right? Okay, so we have x minus 4 squared equal to, on the other side, 5. Okay, 5. So this is getting simpler. At this point, we've isolated what's being squared. How do we get rid of the square? Square root it. Square root it. I can get rid of something being squared by square rooting.
So the 3 cancel out?
Uh-huh. Yeah, we divided by that 3. Those are gone. Now what's left on the left side? If I square root something that's being squared, all that's left is x minus 4. Can you see it? Equals plus or minus the square root of 5, which is probably some number, right? Some number a little bigger than 2, not quite 3. Last thing I need to do before I can say I'm done. Add the 4 to both sides. So our answer here is going to be x is equal to 4, right? So these 4's canceled. We got x by itself. x is equal to 4 plus or minus the square root of 5. X is equal to 4 plus or minus the square root of 5. That's our answer. Okay. I'm going to guess that the square root of 5 is maybe 2.1, 2.2 something. So I've got 4 plus 2.2. That's going to be a little bigger than 6. And 4 minus 2.2. That'll show up on the graph a little bit less than 2. Cool? Okay, let's get one that has better numbers. Maybe you can understand what that looks like. So write down the equation 2, open parentheses, x minus 3 squared equals 32. 2, open parentheses, x minus 3 squared equals 32. Okay, so let's go pretty quickly here. What's the first thing I want to do to solve for x? Divide by 2. That gets rid of the 2 out in front. So I'm going to have x minus 3 squared equal to 16. Ooh. What's my next move? Square root both sides. Get rid of the squared. So what's left on the left? X minus 3. And on the right? Equals plus or minus the square root of 16 is, remember, you've got to have both the positive and the negative option there. Plus or minus 4. Now what? Add 3. Swing the 3. So x must equal 3 plus or minus 4. How does that look? Well, if x is equal to 3 plus 4, that is 7. If x is equal to 3 minus 4, that is negative 1. Okay? So I've got 2 roots. I've got one at x equals 7 and one at x equals negative 1. This is that function. 2 times x minus 3 squared minus 32. And if you plot the roots, you've got one at negative 1 and one at 7. Here you go. Is that better?
Something that confuses me is that whenever you add the 3 on both sides, why don't you add it to the 4?
Because I could write, I see what you're saying. So why am I not adding it to the 4? Because that's positive 4 or negative 4 plus 3. So I'm either going to have positive 4 plus 3 is 7, or I'm going to have negative 4 plus 3 is negative 1. So really it's the same, but we want to put our number in front so that I can then either add or subtract the 4. I don't want to have to think about if it's a positive 4 plus or a negative 4. I want to have a number plus or minus what I've got left. Okay, good question. All right, so that's using the square root property. Everybody okay with that? Okay, we're going to build on it. We're going to build on it. This is called solving by completing the square. Solve by completing the square. Solve by completing the square. This is a rather difficult process, okay? I wouldn't teach this to a regular Algebra 2 class. I would probably bypass it. But it's handy. It's really handy. It makes things a lot easier, especially if you're in a situation where your equation won't factor, okay? Especially if you're in a situation where your equation won't factor. Okay, so let's look at x squared. The equation is x squared plus 4x plus 1 equals 0. X squared plus 4x plus 1 equals 0. So the first thing I'm looking for is, can it factor? Are there factors of 1 that make 4? No. No. So factoring is not an option here. The second thing I want to see is, well, is there a b term? Because if there's not a b term, I'm about to isolate that x squared piece and go with what we just did. Do you see a b term? Yes. So now we have fewer options, okay? Enter this idea of completing the square. So for completing the square, the first thing that has to happen is a must equal 1. A has to equal 1. That's this number in front of x squared. If a is not 1, okay, so if not, you have to divide everything by that number to make sure that it equals 1. Okay, so if I had a 2 right here in front of x squared, I would then go through and divide every piece by 2 so that I was left with x squared in front. Do you see what I'm saying? Okay, so you're not allowed to have anything in front of x squared. The next thing that you're going to do is you're going to kick c to the other side. So basically step 1 here is going to be move c to the other side. Move c to the other side. Leave space after bx. Move c to the other side. Leave space after your bx term. So if I move this c, what's c, by the way? 1, it's the constant caboose. If I move that to the other side, how do I move it? It's positive 1. So I'm going to subtract it. So I'm going to rewrite my equation as x squared plus 4x, leave a big blank space here, equals negative 1. Can y'all see that? Okay, that's step 1. Step 2, identify b. So on our equation, we have x squared plus 4x, big space, equals negative 1. What is b? Not 4x, just 4. So b equals 4. Once you know what b is, you're going to half it, square it, half it, square it, and add it back. Half it, square it, add it. So b is 4. Okay, so the first step here is half it. 4 divided by 2. What is that? 2. Now you're going to square it. What's 2 squared? 4. And then you're going to add it. That's this step right here. I'm going to take that 4 and I'm going to add it. I'm going to add it back here. So plus 4. What I do to one side of equals, got to do to the other side. So I'm going to take that 4 and I'm going to add it to this side as well. Can you see where that 4 came from? Identify b. Take your b term and half it, square it, and add it to both sides. Okay? That brings us to our next page, next step here. So we had x squared plus 4x plus the 4 that we just added equal to negative 1 plus the 4 that we added to this side. Right? Yeah, just call that 3. So on the far right side, now negative 1 plus 4 is 3. But why did we do this? Why did I complete the square? Okay, so everybody look at this now. I've got x squared plus 4x plus 4. I just created a perfect square trinomial. Just created a perfect square trinomial. If I tried to factor this, what are factors of 4 that make 4 in the middle? 2. So what would my factors be? They would be x plus 2 and x plus 2. Can y'all tell I would get the same thing in both places? So instead of writing it as x plus 2, We're going to write it as x plus 2 squared. Now we see where this is going. How can I solve for x? Square root both sides. Didn't we just do this? So we created for ourselves a beautiful little math problem that now we can work. Square root both sides. What's left? Is equal to plus or minus the square root of 3. Now what? Minus 2. Swing the 2. So x is equal to negative 2 plus or minus square root 3. 2 roots. If you graphed them, that's where the thing would cross the x-axis. You would see both of them. Okay? Now let's work through a couple more from start to finish without all the notes involved. Hopefully the notes are helpful. And remember, on your homework assignment, I only let you have the ones that work out really nicely. Okay? I think let's do, just for practice right now, I think we could look at number 10. Number 10 is nice. So this is coming directly off your homework paper. It says x squared minus 10x plus 26 equals 8. X squared minus 10x plus 26 equals 8. So the first thing you're going to want to do is set it equal to 0. Set that equal to 0 and see what happens. So we have x squared minus 10x. What's 26 minus 8? 16?
Yeah. No, it's not. Yeah, it is. No,
18.
it's
18. There we are. 18 equals 0. We want to make sure that we didn't miss something here. When we set it equal to 0, we can tell whether or not we could factor. Can you tell here that we can't? Factoring is not an option. Because there aren't any factors of 18 that are going to make 10. Real quickly, I'm thinking of my factors of 18. 1 and 18, no. 2 and 9, no. 3 and 6, still missing. Okay, can you tell why we can't factor here? So now we are in this place where we need to complete the square. So our first option is move C. Kick that C term to the other side. So we'll have x squared minus 10x, leave a space, equals negative 18. When you move it to the other side, it has to change signs. You're subtracting it from both places. Now, what's your B term? Negative 10. B equals negative 10. So now you're going to half it. Negative 10 over 2 is 5. Square that, which is 25. And you're going to add that 25 to both sides. So plus 25 here, plus 25 here. Can y'all see it? I took B, I halved it, I got 5. I squared it, I got 25. And then I put that 25 back in both equations, in both sides. Now, why did we do that? Because what can we do now? We can factor. We created a perfect square. What are factors of 25 that make negative 10? But they've got to both be negative. So I could have x minus 5 and x minus 5. Or I could have x minus 5 squared. Good. Equals what on the right? 7. X minus 5 squared equals 7. Square root both sides. X minus 5 equals, careful, plus or minus the square root of 7. add the 5 to both sides. So my final answer is x equals, good, 5 plus or minus the square root of 7.
Whenever you were like halving it right there with the
Uh-huh.
percent, it's negative 10 and you have to by 2.
I got negative 5.
Oh, negative 5? Okay,
But did that make you feel better?
yes.
I missed it. It was negative 5, but it doesn't matter. When I squared it, I got 25. But good call. It should have been negative 5. When I squared it, it took care of the fact that I'm a dummy. It's fine. Okay, one more. One more, and we'll call it quits for today. I think that you'll have 3 or 4 minutes at the end of class to like not do anything. So don't be annoyed that we're going to do another one. I'm not. I wouldn't. Nah, you've just been annoyed for the last 30 minutes, but it's fine. K squared minus 4k plus 1 is equal to negative 5. K squared minus 4k plus 1 equals negative 5. So what's the first thing I want to do? Set it equal to 0. You'll have regrets if you don't, because you might do something that's a lot harder if you could factor instead. So now we have k squared minus 4k plus 6 equals 0. So run through real quick. Are there factors of 6 that make negative 4? No. Okay. I don't think that's an unnecessary step, though. I think it's worth looking at. I think it's worth seeing if you can factor. But now that we know we can't, go ahead and scoot that 6 back over to the other side. When we move it, how do we move it? Yeah, minus 6. So now we're going to have a new equation that is k squared minus 4k, leave a space, equals negative 6. Everybody okay? Now what's my b term? Let's see if we can do better this time. Half it. What's negative 4 over 2? Negative 2 squared positive 4. Okay, so your steps are half it, that's going to be this one right here. And then you're going to square it, that's going to be this one. And then you're going to take it and add it back, that's this right here. Add 4 to both sides. Everybody good? So now what do we create? We have k squared minus 4k plus 4 equal to negative 6 plus 4 is negative 2. Ruh-roh, Sparky. So we created for ourselves this little perfect square trinomial, k squared minus 4k plus 4. What are factors of 4 that make negative 4? Negative 2 and negative 2. Hint, hint, they should always be the same. Second hint, they should always equal whatever you got when you have to be. Every time. So if you're struggling with how did that factor, it's whatever you got when you took half of b. It's negative 2. So here we have k minus 2 squared equal to negative 2. Right? Now what? Square root both sides. So I've got right now k minus 2 equal to the square root of negative 2 plus or minus. We're going to add the 2 to both sides. K equals 2 plus or minus the square root of negative 2. I have one issue with this. Can't take the square root of a negative number. That went from difficult to complex. I cannot take the square root of a negative number. So what do I need to do to make this something we can handle? I. Where does the I go? Outside of the radical sign. So this is all going to be just a perfect answer, except that I can't take the square root of negative 2. So it has to come out as I square root 2. I square root 2. So what does that mean on the graph? If I were looking at this function, which I don't even remember what the function was, but if I graphed it, feels like it would either be all above the x-axis or all below the x-axis, and my roots don't exist on the x-axis. I have imaginary roots. Cool? All right. We'll finish your homework in class tomorrow. You'll have time to practice this material tomorrow.